Okay, the first part of today's lesson out of 4.8 is entitled even and odd functions. So let's get some definitions of what an even and odd function are. So the definition that's in the textbook is a little bit complicated. It says for an even function, and what this is saying, and remember our notation here, f of x, that means x is my variable, that if I put a negative value of that in, so instead of a positive x, I put a negative x in, that the actual value that comes out isn't going to change. And an example of that would be, let's say that I have a function and who cares what it is, and I would put a positive 1 into that, and what I would get out, say, would be a 10. And then if I put a negative 1 in, so I'm putting the negative of the value in, I would get a 10 out. So I got the same value out when I put the negatives each other into the function. That would be called an even function. And so this is the notation that the book uses. They say, okay, I have a function, and I put a negative value for the x, whatever the x is, I just take the negative of it, and they equal each other. Remember, really, f of x, we're just saying the y's are equal. And what that creates, as you can imagine over here, let's say this point, I take an x, and I put, say, 2 in for x, and I get a 3 out for y. And then I put a negative 2 in for x, so that would be all the way over here, a negative 2, but I also get a 3 out. That's what this would look like. And you can see that what it's going to do, it creates a symmetry. So an even function is going to be symmetrical about the y-axis. That's going to be an even function. We're going to do an example in a minute. So let's go ahead and now see what we would consider to be an odd function. Okay, so we get some of this strange notation again that the book does. And what it's saying is that, okay, I'm going to put a negative value in for the x. And what that's going to do is it's going to change the y value that I get out to be negative. So let's say, that would be a case like if I put a function and I have 1 into it and I get 10 out, that if I put a negative 1 in there, what I would get out is a negative 10. That changing the x value from a plus to negative, here's what this shows here, from a negative to a plus, that actually it changes the y value, so the whole y value becomes negative. Okay, so another example would be, let's say I put a 2 in and I get a negative 8 out, that if I put a negative 2 in, I get a negative 8 out. Or let's say that I put 2 and I get a negative 8, then I put a negative 2 and I get a positive 8. So putting the opposite values in for x, 2 and negative 2, produces the same number but with different signs coming out. That would be considered to be an odd function. And what that does is that creates a symmetry with respect to the origin. Okay, so it's symmetrical around the origin. Now I could have another case, and that would be, let's say I put a 1 in, and I get a 10 out, and then I put a negative 1 in, and I get a 6 out. That would be neither. It's neither even or odd. Okay, so there's 3 cases. I have an even, I have an odd, or I have a neither. Got it? Okay, so let's go and do an example. And here's one. And I've kind of described what you're going to do. Now, the book is going to always use values of x and negative x. They're not actually going to use numbers. And I'll do in the examples that we're going to do, I'll do one by the x's and I'll do one with numbers so that you can see how that works. But the book is going to say, okay, put a negative value into the equation. Okay, put a negative x in. If the equation stays exactly the same, then it's going to be even. But if the resulting equation that I get is actually putting negatives or changing the value of all the terms, so let's say I have an x cubed term plus x squared minus 1, that if what I get out would be a negative x cubed minus x squared plus 1, that would be like putting a negative on the entire y. Every term changes its sign. Then that would be odd. Okay? And if it doesn't do either of those, then it's neither. So let's go ahead and try one of these. I'll do it the book way. Okay, so let's go ahead. So first thing I'm going to do is I'm going to say, you know what would, if it was an odd function, what would it look like? So I'm going to take this f of x, and this is actually, I'm not actually putting anything into x yet. I'm just saying, okay, I'm going to take the entire y value, and I'm going to make it negative. That's what would happen if it was odd. So that would be a negative of x cubed minus 7x. And what I would get out would be negative x cubed plus 7x. That's what I would expect if it's odd. If it's an even, then I'm going to get the exact same thing that I started with out. So let's go ahead and actually substitute in to the equation negative x. So if I put a negative x in, I am going to get a negative x cubed minus 7 times a negative x. And let's go ahead and simplify that further. A negative cubed would be a negative. So this would be a negative x cubed. And this negative x here and the subtraction in front of the 7 would be plus x. So when I put a negative x into the equation, I got this out. So now let's see if it's even, odd, or neither. So this equation right here, is it the same that I started with? Well, no, it's not. Look, it's not the same. So it's definitely not an even function. All right, so let's look and see if it matches what I would expect by putting negatives on all the terms. And it's a negative x cubed. Yeah, I got that, plus x. Hey, oops, I forgot my 7, sorry. So what it does is it matches what I would think if I put a negative on all the terms, so this would have to be an odd function. So let's see what that means number-wise. Like I said, this is the way, what I just did is the way the book would show how to do it. Let's see what happens if I do a number. So I'm going to put 1 into the equation. So if I put 1 into this, I'm going to get 1 cubed minus 7 times 1. That's going to be 1 minus 7. I get 6. If I put a negative 1, I get a negative 1 cubed minus 7 times a negative 1. That would be a negative 1 plus 7. I get, this was a negative 6. Let's go back to the first. 1 cubed minus 7 is a negative 6. This one, the bottom part, would be a negative 1. Negative 1 times a negative 7 would be plus 7. This would be a plus 6. So those two are the same value but opposite signs. That matches what I had done when I just used x's. It's odd. Let's do the next one. Okay, so I'm going to use the x's first. Then I'm going to go down and do some numbers. So if this was an odd function, I would expect the negative of what the original function is would be this. That would be putting a minus, which would just change the sign on all the terms. Negative x to the 4th minus x squared plus 1. So that's what I would expect if it's odd. If it's even, I would get the original back out. So let's go ahead and put a negative x into the equation. And what I'm going to get is I would get a negative x to the 4th plus a negative x squared minus 1. Okay, so let's go ahead. A negative to the 4th power will always be a positive. I have another negative. It's squared. Well, that's going to give me a positive 2. Minus 1. So this is what I get out. Let's see what it matches. X to the 4th plus x squared minus 1. That's the same as what I started with. So that would have to be an even function. Changing the value of x to a negative value didn't change the value at all. So that's even. Let's try it with a number. So I'm going to put 1 into it. That would be 1 to the 4th plus 1 squared minus 1. That would be 1 plus 1 minus 1. That's equal to 1. Okay, now let's put a negative 1 in. That would be a negative 1 to the fourth, plus a negative 1 squared minus 1. That would be 1 plus 1 minus 1. Hey, I got the same thing out. So changing the value of what I put into its negative didn't affect the outcome. The number-wise, I got an even also. Okay, let's move on to the last example. Once again, this first thing I'm going to do is see what this would look like if it did become an odd function, or if it was an odd function. So a negative h of x would be a negative x cubed plus x squared. And so that would be a negative x cubed minus x squared. That's what I would get out if it was odd. If it was even, I would get the same thing I started with. So let's put the negative x in. And that would be a negative x cubed plus a negative x squared. That's going to be a negative cubed. Well, that's still a negative. And a negative squared would turn it to positive, so that would be plus x squared. And let's try to check to see what that matches. That's not what I started with, that's for sure. Now, does it match what I would suspect if all the values changed to a negative? And no, it doesn't match that either. So this is neither. And let's try a number in there. So I'm going to use a negative and positive 1 again. So if I have a function and I put 1 in it, that would be equal to 1 cubed plus 1 squared is 2. If I put a negative 1 in, I get a negative 1 cubed plus 1 squared. That would be equal to a negative 1 plus 1 would be 0. Those two are not the same. So that confirms what I had already known when I used just the x's. So there's two ways to do it. I can use numbers or I could use the x values.